Well, good afternoon, everybody, and welcome to our webinar on our recently relaunched UKSuds.com website. We're hoping that this short introductory session to the site will give you a good feel for the key tools we have and the improvements we've made recently. We've got a very wide range of people on the line, which reflects the broad spectrum of users of this website, so that's great. And here you'll see our new homepage for the UKSuds.com website. Okay, there seems to be a small problem with the PowerPoint, but I'll keep going. Just to let you know who you're listening to. Oh, here you go. There's Richard, our technical director, the creator of UKSuds.com. And he's been working on and developing and enhancing the tools for several years. There's myself, Bridget, who led the drafting of the manual, and Helen, project manager of the manual, who will be in the background collecting together any questions you might feed through during the webinar. So today we're going to introduce you to the new site, the tools hosted on it, with a particular focus on the most popular ones. We're going to talk through the need for the various tools, what they do, and the recent changes. You are all currently muted in listen-only mode, so if you have a burning question as we go along, then please submit it using the chat box on the right. Helen will be able to have a look at these and then feed some of those through to us to answer at the end of the webinar. If we can't provide an answer today, then we'll collect them all together and provide some generic feedback that we'll post on the UKSuds.com website later. There's also an opportunity on the website to ask questions, technical questions, so you have that opportunity. And if you feel that this webinar didn't quite address what you were hoping, or you need some further detail, then we've got a short survey immediately after the webinar for you to, that you can put your feedback on. The other option is that this webinar will be recorded, so you can listen to the recording afterwards, which might help clarify things. So, who's the site for? Well, principally SuDS designers and SuDS approving bodies that will normally be the local planning authority. The tools provide quick ways of estimating limiting discharge rates and storage volumes. This will allow designers to integrate realistically sized SuDS within the initial development layout at an early stage. And that will then facilitate initial cost estimates and option appraisal. It will enable consistent use of design criteria and provides a mechanism for designers and approving bodies to have discussions both at pre-application stage and planning approval stage. Importantly, it can also provide approving bodies with a useful checking tool to give them confidence that the proposed designs are likely to be sufficient. So just to give you a little bit of background, the site was developed originally following research we carried out on the design of storage for flood risk management, and that was completed in 2002. That project was the basis of setting a consistent national approach to site drainage criteria, rather than the wide range of approaches that had been adopted by regional EA offices before. The two tools used by the great majority of site users are the greenfield runoff and the storage volume estimation tool. And these are the two we're going to talk about today. But first I wanted to quickly make you aware of the other tools on the site. So there's a tool for infiltration volume sizing, and this you find under the Tools toolbar. It allows you to estimate storage volumes for different types of infiltration system based on subgeometry and porosity of fill material and the infiltration coefficient. There's a tool that allows you to evaluate the contribution that rainwater harvesting systems can provide for surface water management on the development site. And that looks like this. There is a site drainage evaluation tool. This is essentially a decision support tool that guides SuDS component selection and can ensure consistent consideration across the different sites of all the risks and the opportunities for SuDS. The input data is shown on the left, and the report that you get is shown on the right, which is a useful summary of all the site characteristics and decisions that are made. There is the water quality evaluation tool that is set out in the SuDS manual, and this spreadsheet automates the simple index approach method, and looks like this. It's also on the Syria website. And there's another water quality tool at the bottom that was developed during a EC research project which a few years earlier, which outputs sustainability index. Many of you will have seen the new site. This is the home page. Hopefully you'll see this as a big improvement on what we had previously. It's been completely refurbished, so it's in line with the HR Wallingford website style. The new recoding allows us to improve the tools more easily and provide the increased functionality for users. To use any of the tools now, you need to register. You need to enter, and you can then enter the site using a username and password. And this allows you access to your account page, within which you will be able to store all the runs that you've undertaken using the tools, and then re-edit those and amend those in the future if you require. There's improved help and support functionality within the site, so hopefully a lot of your questions can be answered using the FAQs that are there. These FAQs are also linked to the individual tools on the site. There is a page of knowledge base and downloads, which has all the regulatory and government guidance and standards documents that will hopefully constrain and drive your design criteria for the site. And if you require further help, there is a page which allows you to request technical support, and there's a separate page if you want some consultancy. Finally, there's a page which is where we're going to put advertisements for any training or webinars that we may be hosting in the future. So I'm now going to hand over to Richard to present the two most commonly used on the site, tools on the site, the greenfield flow estimation and the storage volume estimation tool.
Many thanks, Bridget. Hi, everybody. So the two tools I'm going to talk about for the greenfield flow rates and the storage estimation tool, it's worth probably stating at this point that the purpose of the website is to provide simple tools for non-experts to use so that data can be input and kept to a minimum. So for the greenfield runoff flow rate estimation, the first thing that you need to enter is a postcode, or zoom in on the map and click on the location of your site. With this, the hydrological information for the site is populated into the database, and the only thing that you need to enter is the total site area. Previously, there was a public open space entry, but this is no longer used, though it continues to be used in the storage volume method. As before, the greenfield flow rates can be estimated using one of two methods, the IH124 or the FEH method. The flow rates are reported as in terms of Q bar and the 1, 30 and 100-year return periods. What is new is that there is the opportunity to add a run description for the run and to store the data when you call the PDF report. The report itself has been modified in terms of its style, but the content is as it was before, except that 3 comments are now made with regards to the output that is predicted. So if the minimum flow rate is less than 2 liters per second per hectare, which you would get for sandy soils, a comment is made to highlight the fact that 2 liters per second per hectare is normally set as a minimum. Similarly, if you have a small site, if the minimum flow rate is less than 5 liters per second, then a comment is also made to suggest that the limiting discharge might be set at 5 liters per second. And I will come to this again on the next tool. And finally, there is the comment related to the soil perviousness, and if it is a sandy soil, and I've chosen an SPR value of 0.3 or lower, then there is a triggered comment which suggests that infiltration might be considered for your drainage design. And so we come to the surface water storage volume estimation tool. This is used by many for planning applications because it provides a summary of all the information and data that is used in calculating the volumes. So both parties, the planners and the developers, know what has been used. As before, the site is located with a map click and the hydrological information is populated. There is, however, more information to enter with regards to the site. So what is highlighted at the top in yellow box is the significant public open space, which I referred to earlier, which has now been removed. And in this location, it is added where there are large areas of green space which might be considered to be not served by the drainage system. The top box with the red text in it points to the total site area and the impermeable areas where the minimum has been reduced down to 0.02 of a hectare and 0.01 of a hectare respectively. And this has been requested a number of times because there are small sites which were smaller than the 0.1 of a hectare limit, which had been set before. 0.01 of a hectare effectively is 100 square meters, which is effectively a very large property. The rainwater harvesting and the infiltration data entry is as before, where you allocate the paved areas which are drained to either of these systems, and this is taken into account by calculating a net paved area which is served by the drainage system. The net site area has to check to see whether the site area is very much larger than the net paved area, and if PIMP is not equal to at least 50%, then the net site area is reduced accordingly. And this is because the runoff model assumes 100% runoff from paved surfaces and 0 from pervious surfaces, and you can get more information on this point by looking at the FAQs. So we actually now report both the net site area and the net paved area, and it's important to stress that the Q-bar analysis uses the net site area in its calculation. But finally, there is one box at the bottom which is very important, I believe, because there has been a trend not to use the net site area in calculating the limiting discharge, but to just use the impermeable areas. Now, this is understandable because of the approach that is taken by the runoff modeling assumptions in having 0% of pervious runoff. So what I have added is a proportion of the site that is pervious that can be considered to be continuing to contribute runoff to the drainage system, and therefore you can assume that the remainder of the pervious area is not contributing to the pervious system. So the whole approach is to try and persuade a common approach to still use a net site area rather than use just the impervious surfaces. So to illustrate this, we have on the left-hand side of this diagram the public open space where we have a green area which might be considered to drain as it did beforehand and therefore can be excluded from the calculations. The two boxes that are blue and red might be the areas that be deemed to not contribute runoff because they're in back gardens, the 70%, and the 30% might be the area which contributes runoff still from the pervious areas. And this is taken into account by factoring SPR, by increasing the net site, the net paved area by taking into account the difference between SPR and the 100% runoff. So coming to the hydrological characteristics, I'd like to draw attention to the FEH-FSR conversion factor. This was as it was before. But before, you used to be able to edit this. This was not particularly helpful because you didn't know quite what to edit it with. So we have now added a rainfall data value, which is on the next page, which we'll come to, which allows this conversion factor to be modified by the user based upon rainfall information. The climate change allowance factor is as it was before, except that the default has been raised to 1.4 from 1.3. It's important to stress that the EA guidance on it suggests either a 20% or a 40% uplift, and different local authorities and planners may have views on what should be applied. At the bottom there is the minimum flow rate of 5 litres per second, which has been mentioned before, but due to a number of comments that have been made over the last few years, this default has been allowed to be edited down to as low as 1 litre per second. So coming to the methods of analysis, you'll notice the top box now has 3 methods, whereas before it used to have the 2, IH124 and FEH. There has been a third one, which is called REFH2, and I will come to that in more detail later. At the bottom of the calculation page, you see that there's a rainfall box for the 100-year 12-hour data, and if This will have a value in it which will relate to the FEH FSR uplift factor. But if you enter a value that you know is the 100-year 12-hour rainfall depth based upon FEH 13 rainfall, which is the current method, then the FEH FSR rainfall factor will be modified accordingly. So coming to the REFH2 method, this information can be obtained from the Hydro Solutions website, which is shown here. The method was developed by CEH, and there is ongoing analysis being carried out on this project. But there are no links between the two tools, so you need to enter flow data information manually into the boxes here, as well as the rainfall information for the 6 hours and the 12-hour 100-year events. The REFH tool does not use the value SPR, and therefore it doesn't report it, and therefore this box needs to be filled by reference to the soil information from the IH124 or the FEH method pages, or from another source of information that you might have. So we come to the results page, and it reports, as before, the various flow rates. What's worth drawing attention to is the storage volume calculation volumes have been modified due to some of these changes, and the minimum flow rate of 2 litres per second per hectare is effectively reduces some of the smaller volumes where this cutoff had not been applied before. The minimum flow rates, on the other hand, going down to 1 litre per second does increase storage volumes, obviously. And then the long-term storage analysis takes into account these cutoff rates of flow if they come into use. So as before, we have separate reporting of the methods. Before, we used to report both methods on the back and the front of the same page. Now a report is explicitly related to only the method that is currently being used. So in summary, we have a new website with a new style. We have a registration and account facility to store your results. We've enhanced the tools, and we hope you appreciate what has been changed, but we're always open to suggestions with regards to further improvements or comments on both existing tools and what other tools might be useful. Thank you. Okay, over to Bridget.
Thanks, Richard. Well, while we're waiting for some questions, we would, I just want to point you to the survey that will come up just after immediately after the webinar as it closes. We'd like to hear whether this webinar was useful and whether you would like more to provide further detail on different aspects. If you fill in the questionnaire of the survey, which is only 7 questions, then we'll be able to tailor our future training and e-learning to your needs. Helen, are there any questions coming through at all?
Yes, we do have some questions. I'll start off with one to do with soil classes. What would you recommend people to do when their site crosses a soil class boundary?
Rather tricky one, really. I suppose it depends how large your site is. Clearly, you're going to get, if you do your soil testing, you're going to get slightly different variations across the site anyway. If it's a large site, you can obviously do your drainage using different parameters across the site. But I think I would tend to take a mean unless there was a significant difference in soils across the site.
Okay, and I have another question in relation to discharge rates. So earlier on you mentioned how the tool comes up with a message if the flow rate is less than 5 litres a second. Is that correct? Is it actually acceptable to use 5 litres, less than 5 litres a second in some circumstances?
Yes, what has happened in recent years is that these vortex control units can reduce flows very much lower than 5 litres per second quite effectively. On top of that, there are certain SuDS applications where the risk of blockage is quite small. And to get 5 litres per second as a minimum covers a large area of development sites, so it's sites with quite significant areas, and therefore there is definitely a move towards lower flow rates. But of course, the only thing you need to bear in mind is that if there's a risk of blockage, you need to design it out.
Okay, another question is, do we have any guidance on how to assess infiltration on the website?
Yes.
Infiltration rates. The method for assessing infiltration rates and for assessing the risks and opportunities associated with infiltration is set out quite clearly in the SuDS manual. The decision support tool, the site evaluation tool, asks the relevant questions that might dictate whether or not infiltration is feasible. And then there's obviously the infiltrations estimation tool, storage estimation tool, that you can use to help size your storages and determine the relevant drawdown time of your storage.
And a question related to the area that should be used for calculating runoff. So the question that was asked is, do you use just impermeable area and then paved and roof area?
That's what I was referring to before about the pervious contribution of area, because there has been a move by planning authorities to only use the impermeable surfaces in setting the limiting discharge rate. This, of course, means that your effective site size is very small, which means your storage volumes become very large. So I think it's quite important to recognize your flow rate, your limiting discharge flow rate should be related to your net site area. The difficulty is knowing what the net site area should actually be, but I have made this proposal in my tool to make sure that we include the whole net site area.
Okay, thanks very much, Richard. That's all we have time for in the way of questions. We have had several other questions and points to note that we will respond to as soon as we can by putting something online.
Thank you, great. Thank you everybody for listening, and we very much look forward to your feedback and that we can hopefully join you with another webinar in the not too distant future. Goodbye.
Thanks everybody, bye.